Welcome dear students, we are on the CEC Gurukul lecture. Today's topic is the basics of electronics. We are in this series, we discuss the resistors, the basic important device in the electronic circuit is the resistor. So first we discuss what is the circuit function. Here on the right hand side on the screen we are having a simple circuit which is having a power source, control option, load, indicator that is optional, and the path where the current is flowing. So these are the basic component of the circuit. So in general the circuit can be thought of as a combination of the power source may be battery or a generator, load where the power is used like lamp, speakers, motor, which is also gives the output of that power, and third is the conduction path that connects with the wire. Connection path, all the devices, all the instrument connected with the wires. Then control switches and knobs which decide that it will be start or it will be off, how the current will flow and it will be stopped. Then indicator we use which gives the meters, flashing lights and buzzers. These are the basic circuit of the electronic device. Now in today's topic we discuss the resistors. First we discuss what is the resistance. Resistance is anything that causes an opposition to the flow of current in a circuit. It means resistance resist the current circulate in a circuit, electronic circuit. So here you see in the diagram that voltage, current and resistance both are having a relationship. Then resistance is that device which controls the amount of voltage and current in a circuit. Everything in the circuit has a resistance, even wire. A device which measures the resistance is the resistor. So a resistor is a device designed specifically to have a constant resistance. Then what is a resistor? Resistor is a component or a device which is designed to know the resistance. We can find out the resistance value through the resistor. Those component devices which are specially designed to have a certain amount of the resistance and used to oppose or limit the electric current flowing through the circuit is called the resistors. Resistors basically measure the resistance and it just gives the limit or oppose to flow of the electric current into the circuit. Now resistor is a two-terminal passive electronic component. It is an electronical component that limits or regulates the flow of electric current in an electronic circuit. Resistance we can measure through the resistors. Resistors can also be used to provide a specific voltage for an active device such as a transistor. This is the symbol of the resistor. Now what is the unit of the resistor? The unit of resistor is ohms, that is represented through the omega, and that notation is omega, and when the resistance is large then it is defined in terms of kilo ohm, that is k omega. If it is more then it is represented by mega ohm. So these are the units of resistor or the resistance. Now resistive material, what are the resistive material? Mica, glass, rubber, wood are the examples of the resistive materials. These materials are used to resist the flow of current into the circuit. Now these are the basic symbols of the resistors. In the first left hand side, the first symbol which is represent the fixed value of the resistor. Second arrow is on that fixed value of resistor is variable. It means we can change the value of the resistance. Now photoresistors are also there, adjustable, we can change the value. Trapped resistor is represented in this manner. Then there is a thermistor that depends upon the temperature value also defined by T naught. So these are the basic symbols of the resistor. There are many more different types of resistor and having their own representation. Now, what are the combination of the resistors? They are combined in the series as well as in the parallel. In the series, resistors represent in the series as when they are connected in a chain like structure, that is known as a series configuration, and its total resistance is a summation of each individual resistance, that is R1 plus R2 plus R3, that will define the series equivalent resistance. Next is the resistors in parallel. When the resistors are connected in the parallel with each other such that both the terminals are connected with each other, their total resistance is given by R1, R2 and R3. That this is the 1 by R1, 1 by R2, 1 by R3. These are the parallel resistance. Now, if the resistors are in series, then current remains same. When the resistors are in parallel, then voltage remains same. It means current will same when the resistors are connected in the series, voltage remains same when they are connected in parallels. So, now the important thing which is very important to know that what resistor we are using in the laboratory and what resistor will be used in any particular devices. So, we should know how to read its color code. So, resistor color code is very important to know how we calculate the value of the resistor on the basis of its color code. So, what is this resistor color code? This consists of different colors, significant figures, multiplier value, tolerance value. It means we have three part. Number one is first it's having a color, then on the basis of that color we will calculate its value. So, first we find out its digital value, then second is multiplier value, and third is the tolerance value, and fourth is the temperature coefficient. Any resistor can have these 4 points. First its value, its digit, second is the multiplier value, third is tolerance value, and if it is related to the temperature, then it contains the temperature coefficient, that is used a resistor color code calculator. These points will be used. Now, here you see in the diagram the resistor color code. Here it representation of the resistor band, where the band 1, you see on the left hand side in the diagram that the band 1 represent the first significant number of the resistor value. This is a resistor which is having a black mark or a color code on it. So, we will read this color code by these points. Number 1 band represent the first significant number of the resistor value. Second band represent the second significant number, second digit, first digit and second digit. Now, third digit is also represent the number that can be observed in the 5 band registers of the 6 band register. So, in the 3 we just use the first and 2 digit, but if we talk about the other registers which are of the 5 or the 6 band, then we have the third digit also. Third significant number we will read from this. Now, band 4 represent the multiplier value, that is in the decimal. Fourth is the multiplier value. You are seeing that here on the diagram, the fourth is a multiplier value. Now, band 5 represent the percentage of tolerance value, and percentage of tolerance value that is given for the basically for the none, for the silver, for the gold, etc. That has been given. So, that is the tolerance value. The band 5 will give the tolerance, percentage of the tolerance value. Band 6 represent the temperature coefficient if the resistor related to the temperature. So, these are the representation of the color code on the resistor. So, resistor color code can be used to determine the resistor's ohmic value and the tolerance. So, here is example on the screen, the 1500 ohms with 10% tolerance that has been defined. Resistor color code used to determine the resistor's ohmic value and the tolerance. Now, you see on the screen that here the basic numbers which represent a resistor value. Now, see from black to white, there are the different colors mentioned here. 0129 and 0129, or moreover the third, first you see as a register, first digit represent if it is any color. Here we are having a red color, so its value will be 2. The second is also a red color, orange, then we can have its value 3, then 2, 3, then we will take multiplier value that taken from the yellow, that must be 10, 0, 0, 0. Then we multiply it. Then finally is the tolerance. Tolerance is given gold, silver and none, that 5%, 10%, 20%. On the basis of this, we can calculate the value of this resistance. Now, resistors color coding, here see on the screen 4 band color code is also there, where we are having the 4 values on the register, 4 lines on the register. Now you see the 5 band color code, we are having 5 bands. It means 3 digits, 1 multiplier and then tolerance. And the 6 band color code having the 3 value, next is the multiplier, then tolerance value, and the last one is the temperature coefficient. It is very clear from this diagram. Then we are having the 4 band color code, 5 band color code and 6 band color code. On the basis of that, on the basis of the color mentioned here, we can calculate its ohmic value as well as the tolerance. Now, there is an example. Now, you see on the left hand side A, the 2 digit multiplies by AB into 10 power C. Now, you see here we are having a yellow color, violet and red color. That will be 4, 7, and third one is a multiplier, that will be 10 power 2, that will be multiply it. So, and what is 20%, because none is here, no any color, so we will take the tolerance value is 20%. So this resistor having a value 4700 ohm plus minus 20%. The second B1 you can see 2 digit plus multiplier and the tolerance yellow, violet, red and gold. Now here you see the tolerance change 5%, because here we are having the golden color line on the last, that is the tolerance value will be the 5%. Now register color coding for this brown, black, red, silver, that will be for the brown 1, black 0, then red it will be 0, black for again black it will be 0, for the red 10 power 2, multiplier value it is here for the red, then silver is the tolerance value is the 10%. So the value of that type of resistor which is having the color code brown, black, red, silver will be the 1000 ohm plus minus 10%, or we can write it as 10 kilo ohm plus minus 10%. This is the resistor value. Now here see on the screen, it is very clearly mentioned here the 4 band resistance, where the resistors having the 4 lines color code, and 5 band resistor having the 5 color lines, and 6 band resistor. Hope you are able to understand how we will calculate the color code and how we will find the value from this resistor. Now state the color of each band of the following resistors. These are the some values of the basically of the different resistors present here. Now resistors, what are the purpose of the resistor? What are the main application of the resistor? The 2 main applications are there. One is it is used as a voltage dividers, and second it is used to limit the flow of current in a circuit. Resistor basically limits the flow of current in a circuit. It resists it is stopping, it is limit the flow of current. Now the value of the fixed resistors cannot be changed. There are 2 type of resistor. If it is a fixed resistor, then we cannot change its value. There are the several types of fixed resistors such as composition carbon, metal films and wire wound. Then carbon resistors change their resistance with age or it's overheated. Resistors value can be changed and it may be damaged by overheating. Now metal film resistors never change their value but are more expensive than the carbon resistor. These are the example of the fixed resistor. The advantage of the wire wound resistors is very high power rating. Most of the time it is used in the devices. Then resistors often have bands of color to indicate their resistance value and the tolerance. As already we discussed that there are the bands, color bands on the resistor, and that represent its resistance value as well as the tolerance. Resistors are produced in a standard value, like the number of the values between the 0 to 100 ohm, and is determined by the tolerance. Next, the variable resistors can change their value within the limit with their full value. Variable resistors means its value will be changed. In the fixed, we cannot change the value, but in the variable, we can change the value. A potentiometer is also a type of resistor, which is a variable resistor, which is used as a voltage divider, and most of the time it is used in electronic devices, potentiometer. Now, what is the tolerance of the resistor? As we are talking about the tolerance, then what is this tolerance? The tolerance of resistor is mostly, as we mentioned here, 1%, 2%, 5%, 10% and 20% in older days are common, but these are now rare, means none. Then even 10% resistors are hard to get except extremely high or the low value. That color will be the silver, where they may be the only option available in the sensible prices. Tolerance having the 100 mega ohm resistors with 5% tolerance may be anywhere between the 95 to 105 ohm. In most circuits this is insignificant, but we just vary its tolerance as we required. There is a fairly rare of the audio, it is used in the audio devices, and few instances where such tolerance component can be used. But as the better tolerance power must be 0.1 or we can use for this in the devices. What is the power rating of the resistor? Resistors are available with the power rating of 1/8 watt up to the hundreds of the watt. The most commonly used 1/4, that is 0.25 watt, and 1/2 watt means 0.5 watt, and that will be the most commonly used 1 watt, 5 watt and 10 watt, and this will be used in very less devices where we require the higher power, and it is much often cheaper to use the multiple 10 watt resistors than a single 50 watt resistors. Multiple resistors can be used in place of the single because its cost is minimum as compared to the higher rating one. It is very much easier to obtain also. Like all components, it is preferably to keep the temperature as low as possible. So no resistor should be operated at its full power rating for any extended time. So most maximum power rating must be the 0.5 of which is easily available and possibly used. Now we discuss the type of resistor. Resistors are of two types. Now here we define the types of resistor, in which we define the various type of resistor. On the screen you are seeing the resistor divided into two categories. One is the linear resistor and second is the non-linear resistor. Now the linear resistor is also divided into two category. First is the fixed resistor and second is the variable resistor. And non-linear resistor divided into various categories like thermistor, like photoresistor, LDR, and then it is the varistor resistor and the surface mount, that also defined as SMD. Nowadays SMD are commonly used. So linear resistors are divided into two parts and non-linear divided into four parts. Now fixed resistor, as we discuss the fixed resistor and the variable resistor. Fixed resistor, this is the type of the linear resistor. You see here, linear resistor, fixed resistor and variable resistor. Non-linear, that we will discuss later. First we discuss the linear resistor, that is a fixed resistor having the various type of resistor. This is divided into these four parts. First is the carbon composite resistor, second is wire wound resistor, third is thick film resistor and fourth is a thin film resistor. These are the various types of a fixed resistor. Now variable resistor are of three types. First is a potentiometer, rheostat and the trimmer. These are the variable resistors. Now thick film resistor again categorized into three parts. First is a fusible resistor, second is a cement resistor, and then film resistor, and then it is a metal oxide resistor. And the thin film resistor is also divided into two categories. First is the carbon film resistor that is commonly used in the laboratory, and then is the metal film resistor. These are again the various types of resistor. These are the full category of the resistor as is taken from the site. Now type of resistor. We will define one by one all type of resistor. First we start with the resistors are available in the different size, shape and materials. So on that basis it is defined, it is categorized into two categories, linear resistor and non-linear resistor. What is the linear resistors? Those resistors which values change with the applied voltage and temperature are called the linear resistor. Its value can be changed by applied voltage and the temperature. A resistor which current value is directly proportional to the applied voltage is called the linear resistance. In the linear resistance, the current value is proportional to the applied voltage. Generally, there are the two type of resistors which are having the linear properties like fixed resistor and variable resistor. Now, what is a fixed resistor? Fixed resistor is a resistor which has a specific value and one can't change the value of the fixed resistor. Its value cannot be changed. Generally, they are not costly, small size and occupy the less space as compared to the other resistors. Now, they are reliable and available in the different ohmic and the power rating. So, also fixed resistor can be easily connected to the circuit and withstand for the more voltage. They are used as a component in electronic devices. On the other hand, they are less stable, means their temperature coefficient is very high. Also, they make the slight noise as compared to the other resistor. So, fixed resistor having the various type. First is the carbon composition resistor, second is the wire wound resistor, thin and thick film resistor. So, one by one we will discuss these resistors. So, carbon composition resistor, this is one of the typical type of the fixed resistor which is made from the mixture of granulated or the powdered carbon or the graphite, insulation filter or a resin binder. By using this we prepare the carbon composition resistor. The ratio of the insulation material determines the actual resistance of the resistors. So, the insulating resistors, that is the binder made in the shape of the rods, there are the two metal caps on the both the side of the rods. Thank you very much.